Hello everyone, today we're going to be talking about the sticks and stones method, which is a way of solving hard counting probability problems in many math contests. So let's say we have a problem that says we have 5 people who are all distinct, and we want to give them 6 indistinguishable candies. So first, what does distinct and indistinguishable mean? So that means the people, we know their names, so let's just label them like A, B, C, D, and E. So this means we can differentiate between them. We know A is different than C and B is different than E. But the candies, indistinguishable, that means they're all the same. So you can't tell them apart. So it doesn't matter exactly which candy you give people. So the way you do this is you say the 5 people can be represented by 4 barriers. So let's say the barriers are like this. And then basically whatever's on this side of the barrier goes to A. Whatever's in here goes to B. Whatever goes in here is to C. In here is to D. And here goes to E. So now, if you distribute the 6 candies within these barriers, let's just say you have something like 2 here, none here, 1 here, 1 here, and then 2 here. Well, then we know 2 candies go to A, none to B, 1 to C, 1 to D, and 2 to E. So how many ways can we arrange these 4 barriers that we have, which we're representing by a straight line, and then our 6 candies, which we're representing by a circle? So we know we have 4 of these bars and 6 of these circles or candies. So the number of ways to arrange this is just 10 choose 4, since the bars are the same and the circles are the same. And this is, we know, equal to 10 factorial divided by 6 factorial times 4 factorial. 10 factorial and 6 factorial cancel out, and we get 10 times 9 times 8 times 7 divided by 4 factorial, which is 24. 24 and 8 cancel out, 3. 3 and 9 cancel out, 3. So this is equal to 10 times 3 times 7, or 210. So here's another problem, and if you couldn't tell by the amount of detail and answer choices, it's an AIME problem. More specifically, AIME 10, 2001, problem number 19. So from this problem, you get that there's 3 types of donuts, and you want to buy 4 donuts. So let's say the 4 donuts we want to buy, we can represent them as 4 circles. And now we can put 2 dividers in them to represent the 3 different types of donuts. And this tells us there's 1 glazed, 2 chocolate, and 1 powdered. So now let's just use the same sticks and stones formula, since this is like the same problem as we had before, just with different numbers. So we have 4 circles and 2 dividers. So 6 total objects, and 6 choose 4 or 6 choose 2. They're the same thing. So this is 6 factorial divided by 4 factorial times 2 factorial. 4 factorial and 6 factorial cancel out. 6 times 5 divided by 2, or 2 factorial. And this is 3 times 5, or 15. And this gives us answer choice D. So here's another problem, and this is 2019 AIME 8, problem number 25. And this is a little harder to tell. It's a sticks and stones problem, so let's go through it and understand the reasoning why you would think a problem is sticks and stones. So we know Alice has 24 apples, and he or she is going to share it with Becky and Chris, so that everybody has at least 2 apples. So you can usually tell a problem is sticks and stones if you have some containers, and in this case it's Alice, Becky, and Chris. And these containers are going to hold something that in this case is the apples. And this is the important part. The containers are distinct, so in this case you can tell that Alice, Becky, and Chris are different people. However, the apples, or whatever you're giving to the containers, those are not distinct. And we know in this case the apples are not distinct because Alice did not name them and label them, oh, you're Joe, you're Jimmy, and you're Jonathan. No, you cannot tell the apples apart. They're an apple. However, in this problem, there's a restriction that everybody has to have at least 2 apples. So how will we get through this restriction? Well, in sticks and stones, we have the apples, which let's say are circles, and we have 24 of them. I'm not going to draw them all. And then in this case, we have 2 barriers because there's 3 people. So we know that each side of the barrier here, which is going to Alice, here, which is going to Becky, and here, which is going to Chris, we know each side has to have at least 2 apples to begin with. So let's just give Alice, Becky, and Chris 2 apples to begin with. So that means giving 6 apples in total. So from these apples, we'll minus 6. So we have 18 apples left. And now we can just give them to Alice, Becky, and Chris without worrying about how many apples everybody's going to get. So now we can just perform normal sticks and stones. So 18 apples, 2 barriers, so 20 total objects, choose 2, which is equal to 20 factorial divided by 18 factorial times 2 factorial, or 20 times 19 divided by 2 factorial, or 2. And this is just equal to 10 times 19, or 190. And looking at the options, that is C. And this just shows how powerful sticks and stones can be, and why you need to be on the lookout for it. Thanks for sticking around till the end of the video, pun intended. And today we learned about sticks and stones, which is a very common topic in counting probability problems in AIMC8, Mathcounts, AIMC10, and many other competitions. And we learned that sticks and stones has distinct containers, it has non-distinct objects, we learned how to deal with restrictions in sticks and stones, and we also learned when to use sticks and stones, which is very important. You always got to know when to use a topic. And as a treat for sticking around till the end of the video, here is a homework problem, and post your answers if you get them in the comments below, and I will go along with the solution in the next video. And just to get you started, note that a dice can only roll the numbers 1, 2, 3, 4, 5, or 6. So notice it cannot roll a 0. That is not possible. So each dice must have at least 1 counting towards the sum. So have fun trying, and see you in the next video.